Yeah, 800 turn of coil of effective area 0.05 meter square is kept perpendicular to a magnetic field of 5 into 10 power minus Tesla, and the plane of the coil is rotated by a 90-degree around of its coplanar axis in zero point 0.1 second. The EMF induced in the coil will be, what is the EMF? That this is a question we are going to discuss it now.
In this problem, it is given the number of turns in the coil, it would be 800 turns. The effective area of the coil, that would be equal to 0.05 meter square. Then is kept perpendicular to the magnetic field. The magnetic field in this coil 5 into 10 power minus 5 Tesla. When the plane of the coil is rotated by a 90-degree around any of its coplanar axis for 0.1 second, that means delta t, the rotation time, or dt, or delta t, you can call it a delta t or dt, that would be equal to 0.1 second. What is the induced EMF? Here we need to picturize the diagram for a better understanding. Here we have the 800, this is a turn of coil. The number of turns in this coil is 800. It is the area of the coil is kept perpendicular to the magnetic field. This is the magnetic field B, that value it is given, it is perpendicular, here it will emerge. So that means if the coil is like that, the magnetic field will be like this. So it is perpendicular to the magnetic field, it is shown in the figure. So now what we are going to, we are going to rotate this coil 90-degree along any coplanar axis. Coplanar axis means you can draw this is a coplane, the axis passing through the plane of the coil. If this is the axis, so you can, if this is a coil, if you are consider, this would be the axis. So this is the coplanar axis. Now what we are going to do, we are going to rotate this one. Suppose if you are taking, this is the coil, the number of coil turn. So the perpendicular magnetic field is like that. We are going to rotate this one by 90-degree. 90-degree means it will be turn like that. So 90-degree, suppose if you are considered, this is a, the area factor 90-degree means exactly perpendicular. So for that one, we are going to evaluate for this rotation what is induced EMF, because once if you are rotating, if the magnetic fields are perpendicular to the area, once if you are rotating, the flux will keep on change. Then after 90-degree, the flux will be parallel to the surface, the zero flux. So there will be induced EMF. Hence the solution, induced EMF, that would be equal to, in general it is given minus d pi by dt, or you can call minus the delta pi by the delta t. It is delta pi is nothing but the flux final minus the flux initial. This is the change in flux divided by the delta t. It is given the delta t, it is here 0.1 second. The flux final, it will be 0, because once if you are rotating, if the magnetic flux is perpendicular to this surface, once if you are rotating 90-degree, then it will be parallel, there is no flux passing through this surface. Then the final flux you can consider after the rotation, the final flux pi f, it would be 0. So what would be the initial flux? In general, the initial flux, all the flux are passing through this area, it's a perpendicular, so you can call it is integral of b dot the dE, or it is simply b dot a, because we know the magnetic flux, we know the area. If we have n number of term, because here we are not having single term, if you have n number of term, it's simply nba. So the initial flux, that would be equal to the number of turns 800 times the magnetic field 5 into 10 power minus 5 times the area, it is given, it's a 0.05. If you multiply this to 5 5s are 25, 8 25s are it's a 200, so 200, so here 20 will be the uh, here it's 0.05, then it will be goes to 0, so 200 into 10 power minus 5, that is the initial flux, the number of field lines passing through the area. Once we can check, it's a 0.055 are 25, 825 are 200, yes, then here 20, here 0.005, yeah, it would be the right answer. Now we can substitute here, hence the induced EMF, you can call the EMF, induced EMF, that would be equal to minus the final flux is 0, that would be 0, initial flux now we evaluated, that would be 200 into 10 power minus 5 divided by the change in time, that would be equal to 0.1. So the induced EMF EMF that would be equal to, suppose if you are dividing this one, it will be 2 minus into minus plus, it is 2000 into 10 power minus 5, because it's 0.1, if it is going to the numerator it will be 10, so 2000, then if you are multiply with the 10 power minus 5, it will be equal to 0.02 volt. This is the induced EMF or induced voltage, EMF. So this would be the right answer.
So from the above discussion, we got the option that would be equal to 0.02 volt.